This video goes over the t-test where we're doing means test when we have two populations. So chapters 10, we're going to do problems 12 and 18. I think the original problem I assigned was 11. If you do 11, that's fine. 12 is the problem that we did in class. That's the one I prefer you to do. And so that's the one I put the video out for. So what they want to know is there a difference between the fixed rate percentage and the variable rate? And they collected some data at different banks. And this is the data that was collected at the fixed rate. This is the data. I went ahead and calculated the average. And what we're trying to determine is that if the population mean rate is different. So the null hypothesis is we assume that they're not. That's always what you do when you do means test, and then you try to prove something. The book says they will just prove if they're different. So that's a not equal. That's a two-tailed test. Step 3, we set alpha. Step 3, we calculate our t-stat. How we do that is we go grab data analysis, scroll down to the t-test, equal variances, variable 1 range. Always grab the one that has the largest average. Variable 2. Labels in the first row. I'm going to go ahead and let it put the data, the output right on this spreadsheet right there. There you go. So my t-stat is this. A minute. My p-value, it's a two-tailed test because the alternative hypothesis is a not equal. If it's not equal, you got to use the two-tail, so that's the p-value you want. That's the p-value. It's less than alpha. You want to reject the null hypothesis. The null hypothesis, what we assume is that they're equal, so that means that they're different. So fixed rates are different. In fact, they're higher than variable rates. Problem 18 out of chapter 10 is when we don't have two independent samples, we have the same person and we ask them something prior and then we ask that same person later. When we did this data, this has nothing to do with this one. This number, because it's on the same row, doesn't mean anything. These are different banks or different loans than these. So this row has nothing to do with this row. However, when we have paired data, this number is related to this one because it's both done by this person. So it's paired data. So when we do paired data, what we're assuming is that the difference between this and this, and we define difference in this case by post minus pre. So this minus this is the difference. You need to have that somewhere. What is the difference? It's defined as the post minus the pre. We assume that it's not, and then we're trying to prove that the add changed and increased our attitude. So we're trying to say that this number should be bigger than this one. We're trying to prove that the difference is greater than 0. That's what the problem says. Does the add influence our attitude? Set alpha, calculate a t-stat. You do that by going to data analysis. Do a paired sample. Again, always grab the larger one. In this case, the one that is the beginning, or the we think is bigger, and then grab the smaller one. Labels in the first row. I'll let it generate the data right here. P-value, this is a one-tailed test. Since the p-value is less than alpha, we reject the null hypothesis. which means this is not true, which just means this is true, which means the add influences attitude. The add influences attitude. It does affect attitude. Okay, that's the two problems. There's problem 13, I can't remember. Well, it's the difference between independent samples and paired data, and we've already talked about that. Thanks.